All right, let's dive deep, way deep, into the freezing cold waters of the Arctic to meet one of the most mysterious creatures on the entire planet. This is an animal that doesn't measure its life in years or even decades. It measures it in centuries. We are talking about the Greenland shark. I mean, just look at this thing. It's like a living submarine, a ghost gliding through the darkness. For literally centuries, the Greenland shark was a total enigma. It lives thousands of feet down in near-freezing water, pretty much hidden from us. But just recently, scientists finally cracked its most incredible secret of all, its age. Get this, the oldest Greenland shark they found was estimated to be up to 512 years old. Yeah, you heard that right. That makes it by far the longest living vertebrate on Earth. The old record holder, the bowhead whale, lives to maybe 211. This shark just completely blows that out of the water. To really wrap your head around that, think about this. A shark that is still swimming in the ocean today could have been born in the early 1600s. It was just a baby when Shakespeare was writing his final plays. It lived through the entire Industrial Revolution. It was probably just reaching maturity right around the time the United States was founded. Its life spans entire empires. It's just wild. So, okay, this immediately brings up a huge question. How on earth do you figure out how old an animal like this is? It's not like they have a birth certificate tucked in a fin. For a very long time, this puzzle completely stumped scientists. Now, usually there's a pretty standard way to do this. For a lot of fish and other sharks, scientists can look at their vertebrae. They form these growth bands every year, kind of like the rings on a tree. You just count the rings, and boom, you've got an age. Simple, right? Well, what happens when that just doesn't work? And here is the massive problem. The Greenland shark doesn't have any hard tissues in its body. Its whole skeleton is made of soft, squishy cartilage. That means no growth rings, ever. Trying to age it that way would be like trying to find tree rings in a jellyfish. It's impossible. So the old rulebook was completely out. Scientists had to find a totally new, pretty radical way to tell time. And the answer, the key that finally unlocked this ancient secret, wasn't in its bones or its fins. No. It was hidden in the shark's eye. The technique is called eye lens radiocarbon dating. Here's the cool part. The proteins at the very center of your eye lens, in the sharks, are made before you're even born. And amazingly, those proteins never change. They're never replaced. They just sit there for your entire life. They are a perfect little time capsule, holding a record of the ocean's chemistry from the exact moment that shark was born. So this gives scientists this incredible snapshot. They can measure a radioactive isotope, carbon-14, inside that little time capsule and basically ask the shark, hey, what did the ocean look like when you were born? But here's the catch. A snapshot isn't a date. To turn that chemical signature into a real year, they needed a calendar, some massive, unmissable event that left its mark on the whole planet. And kinda ironically, the key to dating this ancient natural creature came from us, specifically from one of humanity's most modern and destructive inventions. So what you're looking at here is a huge spike in the data right around the 1960s. That is the bomb pulse. Atmospheric nuclear bomb tests back then literally doubled the amount of carbon-14 in the atmosphere, and all of it got absorbed into the oceans. So any shark born after the early 60s has this massive carbon-14 signature locked in its eyes. This gave scientists a perfect bookmark in time. They could say for sure which sharks were born after that pulse, which let them calibrate their whole model and figure out the ages of all the older sharks. Okay, so figuring out how old they are is one thing. But it also helps us understand how they live. I mean, a life that lasts for 4 or 5 centuries means you are playing a completely different biological game. Let this first number just sink in for a second. 156. That's how old a female Greenland shark has to be before she can reproduce. 156 years. That is a century and a half of just swimming and growing. That time scale is almost impossible for us to even imagine. And you can see why it takes them so long. They grow at a crawl, less than a single centimeter per year. This is truly life in the slowest of slow lanes, where growth is measured in decades, not days. Even the way they move is slow. Their average cruising speed, about 0.7 miles per hour. That's it. It's no wonder they earn the nickname sleeper shark. They're just conserving every single bit of energy, moving through the deep with this ancient, unhurried pace. So you put it all together. The slow growth, the slow speed, the super late maturity. It all points to one thing, a profoundly slow metabolism. It's the ultimate energy-saving strategy perfectly designed for the crushing cold and darkness of the deep Arctic. Their bodies even contain compounds that work like a natural antifreeze. They are just perfectly, beautifully built for a long, slow existence. But here's the tough part. The very things that make the Greenland shark so incredible, its long life, its slow growth, taking forever to mature, those are the exact same things that make it incredibly vulnerable. This quote comes from Julius Nielsen, the lead scientist on that huge study. He and his team knew right away that this discovery wasn't just a fun fact for the record books. It was a serious warning sign. And this is where it gets really heartbreaking, because they take so long to mature. When a Greenland shark gets accidentally caught in a fishing net, which is called bycatch, it's not just the loss of one shark. You could be removing an animal from the ocean that's 150 years old, an animal that swam around for a century and a half just to get to the point where it could reproduce, only to be caught before it ever had the chance. And this isn't just a hypothetical problem. The species is officially listed as vulnerable. The biggest threat today isn't people hunting them on purpose, it's that accidental bycatch. And their number one vulnerability is that staggeringly late maturity. A population that takes a century and a half just to replace itself simply can't handle the pressure from modern fishing. So that leaves us with this really profound question. We humans operate on timescales of years, maybe decades, but the Greenland shark operates on a scale of centuries. So how do we shift our thinking to protect a species whose past is longer than most countries and whose entire future really depends on the choices we make today?